Here's a simple React component. We have a count, a button that increments it, and a useEffect that's supposed to show an alert whenever the count changes. Pretty straightforward logic. Click, count goes up, alert shows the new value. Now let's run it. I click the button, the counter updates, but the alert never shows up. Nothing crashes, there are no red errors, everything looks fine, but the logic is clearly broken. And here's the interesting part. Even if this project was written in TypeScript, it still wouldn't catch this issue. TypeScript checks types, not your application logic. This mistake is purely logical. Hi, I'm Dmitrii Balakin, and today I want to show you a tool that helps with exactly this kind of problem. A tool that doesn't care about formatting or code style. That's what formatters like Prettier are for. We covered that in another video. Instead, this tool focuses on the logic of JavaScript and React code. It warns you when the code doesn't match the intent, even when everything looks correct. This is ESLint, a tool that can catch logical issues long before they turn into real bugs. This type of tool is called a linter. It's not AI and it doesn't understand your code. It just reads the file and matches patterns that are known to cause problems. Before we continue, let's quickly look at why this component is actually broken. The issue is right here, in the dependency array of the useEffect. By putting an empty array, I'm basically saying, run this effect only once when the component mounts. But inside the effect I'm using count, so when count changes, the effect never runs again. That's why the alert never appears. If I add count to the dependency array, let me do this, count, and save, the effect runs every time the state updates. And let's try it again. And now the alert behaves exactly as expected. So the fix is simple, but the mistake is extremely easy to make. There's no error, nothing crashes, everything compiles, and even TypeScript wouldn't catch it. This is a purely logical issue. And this is exactly where linters help. Vite already includes ESLint in the project by default. This one, and rules for ESLint. But without the VS Code extension, the editor has no idea how to read ESLint output. So even though ESLint is technically here, it's completely silent. If I install the ESLint plugin for VS Code, I already have it, but I'm going to enable it. Okay. The editor instantly starts showing warnings. Okay, and now let's remove count and save. And right away, it highlights the exact problem. This effect depends on count, but dependency is missing. Now the editor shows unused variables, missing dependencies, and other issues that the compiler wouldn't never warn about. That's the idea behind linting. ESLint doesn't understand your code or try to interpret your intent, it simply parses the file and looks for patterns that are known to be problematic. And issues like missing dependencies in React hooks are some of the most common logical mistakes developers make. We can also run the same check directly from the command line. Let me show this. This is useful when you want a full report of issues in the project or when you're running linting in CI. Since the project was created with Vite and ESLint already included, we can simply run pnpm ESLint and dot. This command tells ESLint to scan the entire project directory and print all the problems it finds. Okay, let's run it. You'll see the same issues the editor was showing. Unused variables, missing dependencies, and other patterns that doesn't match the rules. And ESLint can automatically fix some of these problems, the ones that are safe to change and don't affect the logic. To let ESLint to do that, you can run the same command with fix parameter. Yeah, but our problems ESLint cannot fix them automatically, we need to fix this. Logical issues, like the missing dependency we looked at earlier, still require manual attention, because ESLint can't assume how your code is supposed to work. ESLint itself is just a tool. All it really does is parse your files and report whenever issues the rules tell it to look for. And the rules can be completely different depending on what kind of project you're working on. There are rules for React hooks, rules for TypeScript, for import order, rules for Next.js, accessibility rules, performance rules, pretty much anything you can imagine. You can build your ESLint setup however you like. You can configure ESLint to match your way of writing code. It's completely modular, and that's what makes it powerful. And for example, this is ESLint config, default ESLint config for Vite. It uses JS rules, React hook, and React refresh. You can see it here. And the nice side effect of having a well-configured rule set is that you see problems before they ever reach the user. Even during casual coding session, ESLint quietly points out issues the moment you create them. Not that I ever wipe code without thinking, but if I did, this would definitely help. That's it for today. Thanks for watching, and I hope this helped you understand what ESLint actually does and why it matters. If you enjoyed this, check out the other videos on the channel, and I'll see you in the next one.